Hello, you're watching this video because you're at home, absent, sick, or in quarantine. And so I'm just going to narrate this video and help you through it. Today is either January 21st or 22nd. You're going to need your INB and a pencil for today's class. And if you were in school, you wouldn't need your Chromebook, but obviously you are on a computer watching me right now. Today's agenda is we will add a key concept to our INBs. We will watch a convection current simulation and discuss it, take a virtual field trip around the world to observe ocean currents, and then respond to guiding questions in your INB. So please add this to your key concepts. Your key concepts should be found on pages 52 through 55 for our current unit. Currents spread heat energy throughout the ocean. Currents spread heat energy throughout the ocean. So please go ahead and pause this video if you need more time to add this key concept to your INB. So I want you to come up with 6 differences for how the video model that I'm about to show you is like the ocean and how the video model is different from the ocean. Okay, so I'm going to show a video and I want you to think about how it's like an ocean and how it's different from the ocean and try to come up with 6 differences. And if you were in class, you would share out and we would discuss these. Okay, so did you come up with a list of 6 differences? Check your list against this one here. Of course, the model that I just showed you was much smaller. There's fresh water and not salt water in that basin. Different temperatures of water are not colored differently. Ocean water is cooled and warmed from the surface, not the seafloor. The model doesn't receive heat energy from the sun, and the model doesn't have wind or waves. Earth's uneven heating causes currents in the ocean. And so what hopefully you can see here in this map, and I know that it's kind of covered up here, but these are average global temperatures around the world. And so this uneven heating of Earth is one part of what causes some currents to form in the ocean. So you can see the global average temperatures are -2 up to 35. And you can see the bands of color. And you can see where, obviously, at the equator, the average temperatures are warmer. And at the poles, the average temperatures are colder. Okay, so we're going to take a virtual trip around the world to see over a year of ocean currents from outer space. And the animation begins with warm water at the equator. Surface and near the surface water are shown with white arrows, and deeper waters are shown with blue-gray arrows. So as you watch this animation, I want you to see, think, and wonder. And I'll be asking you questions about your observations, and you can just be thinking of your answers. Okay, so where do you predict the warm ocean water near the equator will go? And what would you expect to happen to the warm water from the equator once it reaches the colder regions near the poles? And finally, where does cold, dense water um, from the Earth, from near Greenland, where does that go? So again, where do you predict the warm ocean water near the equator will go? If you answered it will travel along the surface or near the surface toward the poles, you are correct. And what would you expect to happen to the warm water from the equator once it reaches the colder regions near the poles? If you answer it cools off and sinks, you are correct. And where does cold, dense water near Greenland go? It sinks and moves in currents along the bottom of the ocean. Okay, so this large circulation pattern on this map here is called the Great Ocean Conveyor Belt. And so I want you to notice that the red arrows are on and near the surface currents, and the blue arrows are deep currents. So you can pause this video and just take a moment to study the Great Ocean Conveyor Belt. Why is water dense and why does it sink near the poles? One, it is very cold. Two, when the ocean water freezes into sea ice or evaporates, the salt is left behind in the ocean, causing the remaining water to become saltier. So let's take a virtual trip around the world a second time.